bigger than a house. That is the first thought people have when they see one of these machines moving across a field for the first time. Not a tractor you park in a barn. Not a machine you drive to the feed store. Something else entirely. Something built to consume an entire field before the sun goes down. Most people have never heard the real stories behind these machines, where they came from, what they replaced, what they changed forever. These are 6 of the most important harvest machines ever built. Each one changed agriculture in a way that nobody expected. The combine harvester. Before this machine existed, harvest was a human event. Hundreds of workers, entire communities, weeks of labor just to clear a single large field. The combine harvester appeared in the early 1800s in the United States. The first functional versions were pulled by teams of more than 40 horses. The machines were enormous. The noise was terrifying. The way it works is almost violent in its efficiency. It moves through the field and does 3 things at the same time. It cuts the crop at the base. It separates the grain from the stalk inside the machine. It cleans the grain and stores it in a tank on board. One pass done, the consequences were immediate. Farms that once needed 200 seasonal workers could now operate with a crew of 4. Entire industries built around harvest labor collapsed within a generation. But here is the detail that most people find difficult to believe. When the combine first appeared, farmers organized against it. Some communities passed local laws banning the machines. Groups of workers sabotaged them in the fields at night. They understood exactly what was happening, and they were right. Today, a single modern combine harvester covers more than 40 acres per hour and processes over 9,000 bushels of grain in a single day. The row crop tractor. Picture a field of corn. Tight rows, plants close together, green walls on both sides of a narrow path. Standard tractors could not move through those rows without destroying the crop. The wheels were too wide, the axles too low. Every pass cost the farmer money. The row crop tractor appeared in the 1920s. Engineers at major American manufacturers looked at the problem and built something completely different. High narrow wheels, adjustable axle width, a chassis raised far above the ground so the machine could straddle 2 rows at once and move through the field without touching a single plant. It moved between the crops like it had been designed specifically for that exact space, because it had. The impact was measurable immediately. Farmers growing corn and soybeans reported yield increases of up to 30% in the first seasons after switching to row crop equipment. Not because the machine harvested better, because it stopped destroying the crop while it worked. One single row crop tractor could manage over 300 acres of corn in a growing season without significant crop loss. The surprising detail is where the original design concept came from. Engineers studied the way draft horses walked between planted rows. They measured the distance between hooves. They measured how horses shifted weight around obstacles. The first row crop tractor axle width was copied directly from the stride of a working horse. A machine that replaced the horse was designed by studying how the horse moved. The forage harvester. This one does not collect grain. It collects everything else: grass, corn, stalks, entire plants. It eats the field and turns it into feed for animals. The forage harvester became widespread in the 1960s when industrial dairy farming expanded globally. Dairy operations needed enormous quantities of preserved feed to keep herds alive through winter months. Cutting and storing by hand was no longer possible at the scale required. The machine moves through the field and chops the entire plant into short pieces called silage. As it chops, it shoots the material through a spout directly into a trailer moving alongside it. The trailer never stops. The harvester never stops. A single forage harvester can process over 100 tons of plant material in 1 hour. The consequences of this machine are invisible to most people, but they are everywhere. Every glass of milk, every block of cheese, every pound of butter produced on an industrial dairy farm exists in part because this machine made winter feeding possible at scale. Here is the detail that changes the way you see it. Modern forage harvesters contain a metal detection system built directly into the intake channel. A powerful magnet and sensor array scans every piece of material entering the machine. If it detects a piece of wire, a nail, or any metal fragment, the entire chopping system stops in under 1 second. Not to protect the machine, to protect the cow. A single piece of wire inside a dairy cow's stomach can kill the animal within days. The sensor exists entirely to prevent that. The cotton picker. Imagine a field under a sky so bright it hurts to look up. Rows of white bolls stretching further than you can see, and the bolls themselves are sharp. Every one of them. Cotton harvest by hand tore skin. It was slow. It was brutal. And for most of American history, it was done by enslaved people and then by deeply exploited laborers working for almost nothing. The mechanical cotton picker was developed through the 1930s and reached commercial scale in 1940s. It uses a system of rotating spindles. Each spindle spins at high speed and reaches into the cotton boll. The fiber wraps around the spindle and is pulled free. No cutting, no crushing. The boll stays on the plant, only the cotton comes off. In 1945, one cotton picker operating for a single day collected what would have taken over 50 hand laborers working the same hours. The machine reshaped an entire region. Within 2 decades, over 1 million agricultural workers had left the American South. They moved to Detroit, to Chicago, to New York, to cities where industrial jobs were replacing field labor. Historians call it the Second Great Migration. Demographers trace its acceleration directly to the widespread adoption of the mechanical cotton picker. One harvesting machine shifted the population of an entire country. A modern cotton picker processes over 800 pounds of cotton fiber per hour and can work continuously through the night with onboard lighting systems. The sugarcane harvester. Sugarcane is not like other crops. The stalks grow over 10 feet tall. They are dense, heavy, packed together so tightly that walking through an unharvested field is nearly impossible. For centuries, the only way to harvest sugarcane was to burn the field first, set the leaves on fire, let them burn down to the stalk, then send workers in with machetes while the ground was still warm. The smoke from the burns covered cities. Schools closed on harvest days. Children with respiratory problems were kept indoors for weeks. The mechanical sugarcane harvester was developed in Australia in the 1960s and reached Brazil, the world's largest producer, in the following decades. The machine cuts the base of each stalk at ground level. It strips the remaining leaves using spinning fans. It chops the cane into short billets. It loads everything into a trailer in one continuous uninterrupted motion. Brazil once employed over 1 million manual workers for sugarcane harvest. By 2020, over 90% of the entire Brazilian harvest was done entirely by machine. The number of field workers dropped by hundreds of thousands in under 15 years. But the unexpected consequence was something nobody in the debate about jobs had discussed. The burning stopped. Cities near sugarcane regions reported measurable improvements in air quality within a few harvest seasons after mechanical adoption. Hospitals recorded fewer respiratory admissions during harvest months. The sky above the fields stayed clear. The machine that ended hundreds of thousands of jobs also ended a public health crisis that had lasted for generations. The autonomous harvest system. There is no cab on this one. No seat, no steering wheel, no driver. The autonomous harvest system is not a tractor with automation features. It is a machine that operates alone. It plans its own route. It monitors its own performance. It makes decisions in real time without any human input. The first fully autonomous grain harvest was completed in the United Kingdom in 2021 on a farm in Cambridgeshire. The machine used radar, LiDAR and multiple camera systems to navigate an entire harvest cycle. It worked through the day and continued through the night. No one was in the field. No one was watching remotely in real time. The system managed itself. The field covered over 300 acres. The harvest was completed without a single human intervention from start to finish. Agricultural engineers who reviewed the data afterward noted that the machine's row alignment was more precise than any human-operated equipment recorded on the same farm over the previous decade. Not almost as good, more precise. The performance data from that harvest showed something that quietly ended a long debate in the industry. One autonomous harvester completed what would have required 12 machines, 30 operators, and 4 days of coordinated work. It did it alone, in the dark while everyone slept. And when the sun came up, the field was empty.